All right, here we go. Lesson 2.4. Okay, so this first activity here, we're trying to select three things here, and we're going to try and make this triangle fit. So what I want you to do is I want you to select three things at random here. So, this one, oops, maybe this one, maybe this one, and I don't know. Well, no, let's go like this one and that one. Okay, so I'm going to try and make angle A equal to 40 degrees. So as I get this down here, oh, the numbers are going up. I'm going the wrong way. It's getting skinnier. Oh, it's getting almost to 40. All right, so let's see. Maybe I'm going to have to move some of these other ones around. Okay, so now I've got it narrower. So let's see, getting close, getting close. All right, that's pretty darn close for that one. Now, and then 20 degrees for angle B. Well, let's see, if I move this, oh my gosh, it's changing the other numbers too. Oh, see, as I change that, this is changing. So I have to make sure that I'm just moving up and down on this line right along 40, right? And then, boy, it's crazy. Okay, so I got to get this to 20 degrees. I got to go way down here. All right, so the problem here is that I'm going to be moving all this stuff around. Everything changes everything, right? The length of this side is 3.55, this is 4.82, and this is 3.49. As I move any one of these points, everything is changing. It's crazy, except for the thing that's on the other side. So I tell you what, this right here, I can use this. Let me lock this in. BC, we're going to make this 3.7, and we're just going to lock in at exactly 3.7 if I can figure out how to make that happen. Oh, it doesn't want to do it. Okay. Oh, it's really just not going to do that. Oh, there we go. All right, I got it at 3.7. Now, as long as I don't move either B or C, if I move A around, that 3.7 is going to stay still. Okay, so, right, but all the other angles can change. Okay, so let's see here. 40 degrees for angle A. Okay, so I want to go up here, make it 40-ish, 40 degrees. All right. 40, that's pretty darn close. I'm like 0.04 degrees away. Okay, and angle B is supposed to be 20 degrees. Okay, so that's going to be a problem because look at this. This is like 80 degrees. That needs to be 20 degrees, see, right here. So I'm going to take this way over this way until that gets really skinny here. 20, I'm looking at 20 degrees. 20 degrees, 20 degrees, 20 degrees, 20 degrees. Oh, okay, getting there. 20 degrees, really close. Okay, so I'm really close on that one. And this is also 20 degrees. So how the heck am I going to move this so that this gets to 40? Well, I notice that the further out this way I go, the skinnier this gets, so this angle keeps getting tinier. So if I go this way, let's see if this angle will get bigger. And when I do it, I have to follow this line, because I've already got this at like 20. So I'm going to follow this line right here. Keep it close to 20. Yep, the numbers are going up. Okay, so here we go. I'm following this line, And now, there we go. I'm pretty darn close. So I'm at 40 degrees, 0.03 there, and 20.03. Let me see if I can just get a little bit. There you go. Okay, so that is about as close as I think I'm going to be able to get it. Okay, now one of the things I'm going to do here is I'm going to move these edges so that we can kind of see how long they are. I can't move the angles, but I can move where the numbers are for this. Okay, so take a look at the numbers that I ended up with, right? This edge here is 3.7, because that's what I started with, right? I got my 20 degrees as close as I'm going to get it for angle B, and angle A is 40 degrees or as close as I'm going to be able to get it without driving myself nuts. Okay. Excuse me. Man, I should get some water or something, but I'm going to struggle through here. So what do I notice? Well, I notice that, check it out, angle C is supposed to be 120 degrees. Well, look at it. It's 119.85. So that's pretty darn close. I mean, and why would that be? Well, how come this ended up being exactly, or pretty much exactly what we were looking for here? Well, based on what I know about triangles, right, from lessons in the past, the angles of a triangle on the inside have to add up to 180. So look at this. We got 120 plus 20 is 140 plus another 40 is 180. And so that would make sense that this has to be, about 120 no matter what. Okay, great. Now let's look at our other sides here. All right, this is AC is 1.96. AC is 2. It's supposed to be 2. I mean, that is really close. Like if this was $1.96, basically you're like, give the cashier $2 and, they'll give you 4 pennies back, which is very little, right? And here, 4.97, that's supposed to be 5. So very, 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 very close, right? So what we notice is that if you picked 3 different things, you would still end up with a triangle that looked just like this. Maybe yours would be turned or twisted or flipped or whatever, rotated or reflected, but it would look like this shape, okay? It's not going to radically look different. Like it's not going to be a nice triangle that's equilateral or anything like that, okay? All right, in class, we skipped task 2 and task 3, but the idea here is that there's a triangle, and one person is trying to figure out what it looks like, and the other person is trying to figure out, one person knows what it looks like, and the other person is trying to figure out what it looks like. Okay, so Alina wonders whether she could play the info gap with the area included. I am not going to deal with area right now. I want us to focus on the sides, okay? So we're going to skip task 4, and we're going to skip task 5. All right. Okay, so here we go. Jada and Tyler, they're playing this same game, right? Jada can see this triangle, okay? She can see what's going on with it, and she has all this information. Tyler says, hey, can I have 2 sides and 1 angle? Okay, so Jada says, okay, here, Tyler. One of the angles is 16 degrees. So she's looking at this angle right here. And then she says one side is 5 centimeters, which is this next side right here, right? The angle, and then this side. And then the next side is 4 centimeters, which is this side here. So she tells him this angle, this side, and then this side, okay? So he goes ahead and he does this. And he's like, okay, I got an angle, 16 degrees. My next side is 5 centimeters, okay? And then my next side after that is going to be 4 centimeters. So he connects it up, and he ends up with this shape. And we can see that these two do not match, right? This triangle is not going to lay perfectly on top of that triangle there. This angle might be the same as that angle, and this edge here is the same as this edge here. But this, right? So if you look at this, You got this 16-degree angle, and then the next angle over here is 143. That's a really obtuse angle. Here's 16 degrees. You go down the 5-centimeter side, and then suddenly you have this super skinny angle. I think it's even skinnier than 16 degrees. It's certainly not a 143-degree angle, right? So definitely, right? It's definitely not congruent. It is definitely not congruent to this one, right? Did he do anything that doesn't match her instructions? I don't think so. I mean, he He said, I'm going to take the 16-degree angle. He mapped it out. And then he put the 5-centimeter segment on that edge. And then he put a 4-centimeter segment on that edge. Boom. And then he just connected the ends and he got a triangle. So the question, though, is how could he have been more specific to request 2 sides and an angle so this triangle was guaranteed to match Jada's? Well, this is a tough question, and we will get to the bottom of that question once we get into some of the later lessons in this unit. But work on the, move on to the practice problems, and you are good to go. Okay?